Howdy again, welcome back to Studio G, and this is tips number 1058, and it's about the third or fourth video in this series about this cute little South Bend C9W lathe. Hopefully you have watched those other videos, because I'm going to continue today and show you a few more things on this machine, and then I'm going to promptly sell it after perhaps one or two more videos, and that's it. So keep your eye open for my videos where I have a peat bait and will sell this if you're interested. And I'm speaking to people in northern Illinois that would pick this up. All right, let's get started. I want to show you a few things here in regards to the compound. I'm not sure why they mounted the drum switch up high, although some machines have that type of setup, because this is the way it would have been shipped from the factory, mounted right onto the ways. In fact, the little bracket is still on here, so it could easily be taken off of this pipe and put back down to where it belongs. I'm not going to do it, just wanted you to know that. You see? Here's the little V that would fit right onto the way. I'm going to take the compound off. I've had it off already, obviously, but in order to remove it, and there are several things I want to show you about it, we loosen up these two square-headed bolts and back them all the way out. These are the locks, of course, for the compound. I'm sure you already knew that. And then you need to get those pins out of there so you do not lose them. And I like to use a little magnet, or you probably can just wiggle this and get it to come out, but I prefer to remove these. There's one, and there's the other. Do not lose these, because actually they're a hardened dowel pin that's been ground to, I believe it's 45 degrees, I'm not totally sure. But there's also a bit of a radius here. Perhaps you can see it, so you don't want to lose these, because you really can't make them very easily, I would say. And they certainly will not be available unless someone is remaking them on eBay. And then you can take the compound off by simply turning it and wiggling it, and off it'll come. Some are easier than others, and there we go. You can see I've got plenty of oil on there, and while I've got it off, you know, this is a round dovetail, and this is how those little pins fit in there. So now perhaps you can understand why they are concave and at an angle, and it's quite an effective method. But when you reassemble this, make sure that you orient these correctly so they come into the dovetail like that, not like this, which probably would damage the dovetail. Originally, I was going to totally disassemble the compound, but I've done that in so many other videos, I'm not going to do it. But if you wanted to do it, of course, you'd have to take out the gib screws and the gib and disassemble this screw right here. And by the way, I wanted to tell you that in order to remove these screws on South Bends, you see there's a slot, but there's a hole in the middle, so you have to make yourself a screwdriver. Just take any old screwdriver and grind it with the Dremel, and then that allows you to loosen those screws. I'm not going to do that now, just telling you about it. And by the way, the screw in here, since I do not intend to take it apart, looks pretty much like this. You can see they're not very long. I'm not sure if this is the one off of this model or not, but it would be similar. And here's another example of it, and you can see now that this piece of brass here is the nut. That's all I'm going to say about that, other than I'm going to clean this thoroughly and then re-oil it before I put it on, and I will dress it a little bit with this stone. Well, actually, I've already done that, but I'll do this one for you right now. There's not much to it. So I'm going to wipe the oil off. Now, there probably won't be many nicks on there because this has been covered, but to me, it's good practice to take a stone, and that will remove any high spots. Do not do that with a file. And that's all there's to it, and I already did this a little bit, but you need a smaller pocket stone to get around there, and that may or may not even be necessary. And I'm not going to take the cross slide off. Originally I was going to, but again, I've done that so many times. But I wanted to point out here that here's a screw that goes into the cross slide, and you can see that this is the nut right here that sticks right up. You're seeing at the very top of it, and the whole idea here is that you can take this screw out, and when you put oil, that's an oil hole, the oil will go directly down onto the screw. You can see the screw in there. And while you got the compound off, this would be a good time to oil it, because you can put oil directly onto the screw, as you can see. Now I moved the cross slide a little bit forward out of the way, and you can see how black the oil is here. Probably should take it all the way off, but not totally necessary. So clean out all the old oil, and we want to get oil right in to the dovetail and spread it around a little bit. There's an oil hole here. I've already oiled that a couple days ago, actually. And that's as far out as it will go. So I'm going to clean this real well. There's a lot of gunk here, as you can see, so I want to get that all out of there before I re-oil it. Well, I've had a total change of heart after seeing that black gunk, and I got to feeling guilty, and I thought, well, I will take the cross slide off. After all, I've already loosened the 5 little set screws right there where the screwdriver was, and then it's just a matter here of moving all the way out until it's free of the thread, but you have to back off the gibs in order to do that. So let me take this off, and you can see how dirty that is. I'm glad I'm taking it off. And when I flip it over, there are the 5 screws backed out. There's the gib, and there's the brass nut, and all the filth that we see right here. So I'll wipe this off real quickly, and then I'm going to do this off camera because you don't need to see that. But here's the gib itself. I think you all know what a gib is. It's really dirty, and I'm getting a little bit farther into this than I had planned, because this is really only meant to be a superficial cleanup. Okay, the cross slide is cleaned up nicely, and now my hands are dirty. So that's all been thoroughly and meticulously been cleaned, and now I'm going to get plenty of oil into the dovetail. And same thing here. And I'm going to rub that around real well, like that. And then I'm going to take the gib, and it'll only go in one way, and I usually get it wrong the first time. Oh, I actually got it right. So it goes in there just like that. I need to hold that in place while I take this part of the compound and get it started on the back side. And while I'm at it, of course, some oil on the screw itself. And yes, you could take the screw out if you want, but you run into a lot of little difficulties when you do that. I would avoid it if I was you. See how I'm holding the gib in place with my fingers, and it's in the 5 little screw holes. And I bring it up to the screw and let the screw get engaged into the nut. Now there'll be all kinds of oil running out of there after I'm done, and I'll just wipe it off. But that's really the correct way to do. Take the whole thing off, but it's just a dirty mess, and I was trying to take a shortcut and it backfired on me. And similarly, this is wiped off. It's already been stoned. So we'll get a little Earl on there and here, rub it around. And the compound can be put in place. Maybe. By the way, there's a little protractor here. Make sure you clean that up a little bit with some wire, steel wool, and then the pins go in again in that direction, and pack it down with your ramrod. Same thing on the other side, and then we'll engage the square-headed screws. And I'll be right back. It's standard practice with a South Bend lathe to set the compound at 29 degrees to the right, which is in that area. And the reason for that is that 29 degrees is the angle we set at it for threading, so that way it's ready for that. But we just do not want these two ball cranks to be in the same position. They interfere, you're going to pinch your fingers, and you'll end up swearing. So set that for 29 degrees and lock the two bolts. Well, I immediately had to loosen them up again and get this out of my way so that I can adjust the 5 Gibbs screws with a real small screwdriver. And I'm going to start by just snugging them all the way up. Well, that's not very far, but just bringing them in until they are in contact. In other words, like the slack is taken out. Don't tighten them too much, and they need to be tightened evenly. And I'll do the other 3 off camera. Be right back. And take your time doing this, just moving each screw a minute amount. That is just, 10 degrees or so. Again, all of them the same amount until it feels okay. It should not be locked, and it should not take 2 hands to force it. And that feeling will come with experience. And that is just right. You certainly don't want any kind of movement. There's going to be some backlash because there's wear in an older machine. All right, I'm done with that. I'll wipe everything down and set this for 29 degrees, and let's move on. Let's talk about the bore real briefly. It is a number 3 Morse taper. Now this is a Morse taper reamer. Now we really can't use this to clean up the spindle. Why? Because it's hardened, and so is this. So we probably would ruin the reamer, and it just wouldn't do any good. But if it was buggered up or galled, that would be the ideal solution. And in fact, we will do this in the tailstock in just a few minutes. But what I'm going to do now is to take a paper towel and put a little thinner on it and push it through with the ramrod. Now, if you do not have a ramrod, this is off one of my other 9-inch lathes, but it's a brass end, and it's 12 inches long, and it'll go into the headstock end, and the purpose of it is to drive the center out of there. But I'm going to drive the Kleenex out of there. Clean paper towel, and if you use a screwdriver, you can rotate it. And I'm going to push it all the way through, and then a clean piece back out. You ought to do that regularly because you get chips in there. And you can see how much, that's not real dirty, but it's not clean either. I'll take a clean rag and do the same thing from the other end. But remember, the Morse taper seat in there is only about that long. The rest is rather crudely made in comparison. Okay, enough of that. That's done. And it wouldn't hurt to put just a little bit of oil on your finger and wipe it. You do not want rust in there. I probably should explain this right now, but in order to put a number 2 Morse taper center in the spindle, we have to use a sleeve adapter, and here it is. And that changes a number 2 to a number 3. Make sure they are clean when you put them in there. But what I wanted to explain here is the ramrod has a step on it and a pilot, and the purpose of that is that when you ram this out, the pilot is supposed to knock the center out of the sleeve, and then the sleeve gets knocked out. Now that may not always happen, but that's the general idea of why a ramrod is made in this manner and configuration and shape. All right, let me pull the quill out. I've already done that. I've cleaned it up a little bit. It was stained right here pretty badly, but this will come out very easily. Just run it so that it comes off the thread that is in there. That's all we're doing. Remember, there's a keyway on the bottom. But before I put that back in, let me explain something here, and I'm going to take the tailstock off again. And there it is, and it's in quite good shape on the bottom. Not perfect, but on some of these older lathes, you're going to feel with your fingernail a step right there, where the bottom of the tailstock has worn considerably. Now there will be some wear on this, and I'm going to get back to that in just a few minutes when I do some dial indicating, and I'll refer to this again, and you'll see why, because some of that wear will show up when we measure with a dial indicator. Now I'm going to go ahead and put it back on, and when you do put them on, make sure that you have cleaned the ways thoroughly and then oiled it, and same with this. We do not want any chips or swarf under there whatsoever. You may have watched a recent video where I actually drilled some holes in one of my tailstocks so that there would be an oiler. So that, in other words, we could have a Gibs oiler right here, give it a good squirt, and oil would be directly applied onto the bed. But since this machine is not built that way, I like to put a little oil right here, like I just did, and then with this nut loosened up a little bit, see, I can lift it up and bring it right onto that oil, and it's just as slick as a shuffleboard. And then, of course, it can be locked. By the way, this machine is old enough. Many people told me it's 1940. They did a study on the serial number, which is right here. So it's 1940 or 41, and the machine's old enough to where it has the dauber hole. The dauber, of course, is missing for the tailstock lubricant, which they used to use white lead. So, as I said, this has already been cleaned up, including some solvent into the thread, and I blew it out and then put it back together and oiled it. You'll feel that when it hits the key. And always a little oil, not so much that it's a mess. And while it's out, I should have shot some oil into the thread, but this oiler allows you to oil directly onto the screw itself. Okay, this is a number 2 Morse taper. There's a number 2 Morse taper drill. I'm not going to put that in there because it'll contaminate that, but this needs to be cleaned up. I just ran across a whole box of these that I brought back. They belonged with the green South Bend, and I just recovered them. Oh, there must have been 50 in there. I won't bother to show you. But what I wanted to talk about, the reason I'm showing you this, sometimes when you're drilling a large hole on a small underpowered lathe, the drill will slip inside the quill. When that happens, there is quite often damage. We call it galling. So if your tailstock quill is galled, you need to clean that up, and the way to do it, this is soft, it's not hardened. Here is a number 2 Morse taper reamer. These are kind of pricey, but if I stick that in there just gently, don't hit it hard, and I don't even need a wrench. I'm just using my fingers to remove any little burrs that I might feel in there, and it is pretty good. So I'll take that out And I'm going to wipe that with a paper towel. I will not show that. Okay, this is one of the centers that came with this machine. It was very rusty. I put it into Evaporust, cleaned up nicely. But Bubba destroyed the tip on it a long time ago, many years ago. Might have been Bubba's father even that did that. But I intend to, in a future video, at least tentatively, intend to grind this with a tool post grinder on this machine. Watch for that video if I follow through. You know, I know sometimes I tell you I'm going to make a video and then I get discouraged. For instance, if nobody watches this video, I'm certainly not going to go ahead with this. But the idea here, again, I've already cleaned this out and clean the center, and this center is better, but it's not good by any means. It doesn't hurt to have a drop or two of oil on here, because what sometimes happens in industry is somebody will put the center in there and it'll stay in there for 40 years. Well, if it's been in there for 40 years, you may never get it out. But once you put it in and everything's clean, take your soft hammer, preferably a lead hammer, and tap it into place. You don't have to overdo it. It's kind of self-tightening. And when you do want your center or your drill or your chuck or whatever it is out of there, of course you just back up the, did you see it pop? And it will come out. All right, enough on the tailstock and enough on the carriage. Let's move on one more time. Some of you may have never seen this before, but an option on South Bend lathes was a collet attachment, and here's the drawbar. I've already put the thread protector on, and this is the adapter, and I've already cleaned that and pop that in there like that, and these are 3C collets. That's a 3/8. So the drawbar goes in, the headstock in like that. There's a bearing right here, and there's a keyway, and then there's a key in here. This is 3/8, I guess I said that. And you'll see why in a minute. So there it is, and these are called draw-in collets. I have a complete set. These collets do not come with this machine. This was taken off one of my other machines, but they fit virtually all 9-inch lathes. South Bend's, that is. Now I'm going to check the tailstock offset. As you know, tailstocks on lathes are made in two pieces. There's a bottom right here and the top. So and there's a little registration mark right here, a little graduation, and you can easily make your adjustment according to that, but it's never very accurate. I'm going to show you how to do it with a dial indicator, but when we get ready to do it, you have to loosen up the clamp here, and then using 2 screwdrivers, where's my other one? Put 1 screwdriver on this side and 1 on the other side, and I work them back and forth against each other, but I'll be watching my dial indicator when I do that. Now, you will not be seeing this during the demonstration, but it's almost always necessary to use an indicator. So here's what I will be doing when I change the offset. I'll be using 2 screwdrivers, 1 against the other. Don't try it with just 1. I mean, screwdrivers are cheap. That'll make it easier for you. Why is it necessary to align the centers? Well, if you do not align them and get them pretty darn perfect, when you turn a workpiece, let's say this, you will get a taper. Now, you're probably going to get a 1/1000th or 2 taper no matter what you do, but one of the methods of turning a taper on a lathe, any lathe, is the offset tailstock method. So you do not know what the last person did on the machine. So you ought to check that periodically, especially if you're in a shop where more than one person is using all of the different machines. It won't change in your home shop if you're the sole user. Now, there's many different methods of aligning the 2 centers. I have shown endlessly the method with a test bar, and more recently I've been using that nice red one, edge technology. It works great. It's just I've shown that demonstration so many times, I think I'm going to show you how to use an indicator right now. Not think, that's what I'm going to do. Now don't turn the machine on when you do this. There's different ways you can do it with different indicators. Do not try this, because what happens here, I guess I'll do it this way. See, we're going to sweep the inside of the bore with the probe on the end of the indicator. So you can get your setting here on this side and read it, but as you rotate your spindle, your indicator is not visible anymore. Well, you either got to walk behind the machine, or if you use a mirror, don't use a mirror because you will be confused by it. And I'm telling you, do not use this method. Use a coaxial indicator if you have one, and that's what I'm going to show you right now. Admittedly, they are pricey, but they're worth every penny. Buy one from Shars. The genuine ones, the original one, is not affordable by you or me. So this is a coaxial indicator, and notice there's a stop on here. Again, do not turn the machine on. This will keep this from rotating, and I'm always going to rotate the spindle in this direction. Now there are many different probes included in the kit. I'm just using a straight probe. I will zero in on this closer so you can see it. I know there's a lot of reflection. So I'm bringing that right in to the bore just a little bit, make sure there's no burrs in there. And I will snug this down just a little bit because I'm going to have to loosen it when I make my adjustment. But for now, that is snug. And it's touching the far side right now. And I want to rotate it toward me, and then we'll compare the two. I will zero out the indicator. Okay, I'm touching the far side of the bore. You can see I've zeroed it out, and I'm going to rotate the spindle 180 degrees. And there it is, and I'm about 6/1000ths off. That's not a whole lot, but you remember that on the end of the tailstock, it looked like it was on zero. And that's right, it just looked. It was not. It's 6/1000ths off. So now I'm going to use the 2-screwdriver method, but I have to unlock the clamp, and I will bring the needle to between, well, about 2.5 I'll probably never get it perfect, but you need to get it within about 1/1000th. Okay, watch the needle. I've got 2 screwdrivers, and of course you can't see, and I almost always turn it the wrong way to start with. You know, there's a 50-50 chance, and I always do it the wrong way. Oh, that was correct. You see it move? And now I'll tighten them against each other, and I'll rotate it, and we'll see if we got closer. Okay, let's zero it out. I got to get my glasses on. And I'll rotate it 180 degrees. And I'm almost 2/1000ths off. So off camera, I'm going to use the 2-screwdriver method again. Okay, it's right on. You might see just a little bit of wiggle, but I'm on zero on the fore side, and I'm just about on zero on this side. So that's about as close as a fellow's going to get it. I can hear you now saying, well, I saw the needle move. So that's what I wanted to show you in regards to the wear on the bottom of the tailstock that I talked about 4 minutes ago. So I'm going to bring this down into the 6 o'clock position and zero it out. And now I'm going to rotate the spindle 180 degrees till the probe is at the 12 o'clock position. And it's 6/1000ths off. What that means is there is 6/1000ths wear on the bottom of the tailstock, and there might be wear on the bed as well. And that cannot be corrected. Some people do put shims in here, but that's kind of shaky. that's not something I'm going to worry about. You're going to run into that problem on just about every older machine that you look at. But I was real pleased at how close I had it here as far as the tailstock offset. Okay, this is the coaxial indicator. I bought it from Shars. I think it was $140. I don't remember. It's quite a while ago, but I love this thing. And it comes with, I already loosened that up, several different probes, some extra long ones, curved ones. And this is the part that keeps this from rotating. A nice fitted case with a little wrench and just about everything you need. This really is an indicator that would be used more on a milling machine than a lathe, but this is a nice application for what I have just shown you. And it can be used with the machine running on a Bridgeport mill, but at a relatively slow speed. Very easy to zero in your work on a Bridgeport using this. Well, that completes this video on the several items that I showed you here. I hope that meant something to you. Things that you can do on your own lathe, South Bend, or even other brands as well. It's pretty universal. Thank you for watching. And remember, I have 15 or 1,800 other videos. Check them out. And I'll see you in the next chapter. So long for now.